Hey everyone, in my last video, I covered non-blocking code versus blocking code in JavaScript, and I quickly covered promises, but looking back, I think I could have spent a lot more time covering promises. So today I wanted to cover what promises are and how we can use them to better write asynchronous code. Some context before we start. JavaScript didn't always have promises. I believe that was introduced in ES6. So before promises, we actually had to write asynchronous code in JavaScript through callbacks. So with that being said, let's spend some time looking at how we may write asynchronous code in JavaScript before introducing promises. So in this file, I have three functions. I have getUser, getPost, getComments, and they all essentially do the same thing. They have a set timeout call that is set to resolve at 1 second, and after 1 second, all of its internal code will fire. And each one of these functions has this callback function that is ultimately being called, and it is through the use of these callback functions that we can mimic async behavior along with set timeout. Just remember that in this example, we're using set timeout to mimic asynchronous behavior, but in the real world, think of a network request or input output. And we'll look at a full-fledged example at the end of this video. So just looking at these functions, it may not make a lot of sense what this code is doing, but if we want to actually write some code, it'll probably make a lot more sense if we actually use these functions together and try to draw an example that makes sense. So as we can see in this app function, we have getUser called, and getUser ultimately has a callback that is calling getPosts, and getPost ultimately has a callback that inevitably calls getComments. And I'm not sure if anybody else has realized it, but this innately is very unreadable. It can be very, very hard to track what's going on. And in my opinion, one of the main reasons is why when you write callbacks like this, the behavior that is typically defined within the function signature is also mixed with behavior you define when you're actually calling these functions. Meaning that where we define functions and where we call them, we're doing very similar things because within us calling, for example, get user, we're also declaring the code that is ultimately going to run within its callback, which is everything in these brackets here. So this is innately very confusing. Even articulating it right now, it can get very easy to get confused because the code doesn't necessarily read very well. And if you have a large code base, this is probably not a good idea for you to do consistently every single time you want to write asynchronous code. So knowing that, I don't necessarily think this is a great idea. Let's try to refactor this file and do the exact same thing we're doing in this file, albeit, this file looks very poorly. Let's do the exact same thing, but instead of using callbacks, let's use promises like ES6 introduced. Before we try to convert those callback methods into methods that use promises, let's look into the basics of promises and how we can use them to write async code in JavaScript. So in this file, I'm declaring a promise in line 4. A promise in JavaScript is simply an object, so we declare it using the new keyword. And the promise object takes in a method that gives us access to the resolve and reject method. And whenever we want a promise to fire or successfully finish, we call the resolve method with the desired value. And the same thing goes for reject whenever we encounter an error. So a promise is what we'll use to actually write asynchronous code, since the way we can use promises allow us to write code that won't force us to be in callback hell. But with that being said, we declare a promise in line 4. Let's see what happens if we immediately just log the value like I do in line 14, and why that may not be a great idea. So as you guys can see in the terminal, we ultimately get the promise object in a pending state. As the comment states, guys, on the top, a promise is an object that will inevitably represent the completion of something asynchronous. So it doesn't immediately resolve, it will just inevitably resolve. So knowing that, it can be in 3 different states: pending, fulfilled, rejected. And if we want to actually use the resolved value from the promise, we can't simply just log the promise and say promise.value, for example. That's not even a property. on the promise object. If we actually want to use the resolved value, either the resolved value or the rejected value, we have to use the then method that's actually attached to the promise object itself. So let me actually uncomment the line on line 18. And as you guys can see, we have the promise object, and then we call the then method. And the then method is a method, like I said, attached to the promise object that essentially allows us to define the code that will run once the promise has resolved. It also gives us access to the resolved value. So for example, if we were to run this line of code, we'll see that we get access to the resolved value. So it'll say console log in then block and 20. And if for whatever reason, since success is false, this catch block will actually fire. It'll say in catch block, and then it will say promise rejected. So let's actually test that out, and let's actually run this file now just so we can see it. So as you guys can see, we say in catch block and promise rejected. Why? Because the success variable was false. So instead of resolve being called, rejected was called. Let's actually change the success variable to true. And let's see what we get now. As you guys can see in the terminal, we say, or we get in then block 20. So this is how we would use asynchronous code, or this is how you would use a promise in JavaScript and ultimately use the resolved value from a promise. So you don't end up in callback hell. One thing I will note is that right now we're using the then keyword or the then method to define asynchronous code, but later on in a different video, I'll fully cover async and await. And one final thing, this line 18 will run non-blocking, meaning that this will not block any other code that will fire. So I can actually prove this by quickly just console logging at finished, and we'll actually see this line 20 first before we see anything from line 18, just to prove that this is actually running asynchronously. So as you guys can see, the first thing we get is actually at finished because line 18 is non-blocking. So that's pretty much the basics of promises. Now let's look at how we can change those ugly callbacks to actual methods that return promises. So as you guys can see, we have a new file, and in this new file, we have three functions: get user promise, get post promise, get comments promise. These functions serve to essentially mimic the same functions we saw in this callbacks file, as you can see, with a set timeout call and a callback call. However, in this file, instead of using ugly callbacks that we actually have to define within these functions, we can actually just return a promise. So like we saw in the earlier promise example, we can actually just return a new promise. In this example, again, we're using set timeout. I apologize for spamming set timeout as an example. I'll promise I'll show a quick example of how we can do this with an actual real world data. But for now, we can see that we have set timeout, and at 1 second, this resolve function from the promise will be called with this actual user object. So this is an example of how we can actually get this user object. And since we're using TypeScript, the type would be promise, but promise of user, meaning that this function returns a promise that will inevitably resolve to a user. So if we look at actually the app code or these two functions, I have two functions, app with messy promises and app with clean promises. This is just to show an example, like I said, how we can use promises in the then method or the then keyword, but we can still do it in an incorrect way or a bad way if we're not careful on how we write our code. So one thing to keep in mind is that we don't want to deep nest promises like this, even if we're using the then keyword, even if we're not using callbacks, because even though this is, I guess, a little bit better than, let's say, this, it still kind of looks the same, and it can still be kind of hard to track where this user object may be coming from, where this post object may be coming from. So we don't want to really call the then keyword or deal with promises with deep nesting. If we want to deal with promises in JavaScript, we want to do this flat. We don't want to do this in a way where it's nested. And you can tell it's nested in JavaScript because just look at the indentation. We don't want it to indent like that. Each one of these function calls should be at the same level, if you want to say. So since each one of these functions return a promise, we can actually just chain the then methods for each one, meaning we know that get user promise returns a promise. And then in this then callback, we get the user's object and we get we call get post promise. When we call get post promise, that also returns a promise, and it returns an array of posts, which is exactly what we get here. So if we have functions that return promises, we can just flat chain these ven calls. And as you guys can see here, this code is a lot cleaner than the code here. And this also makes it pretty clear that this is code that is inherently going to run async. All these ven callbacks or these ven methods kind of with their indentation also show that, hey, this in its own block, this code is going to run in its own block and it has its own asynchronous dependencies. Any code that runs after it, like for example on line 62, hello, other code firing, that will fire first actually. It won't this line 57 all the way up to line 60 won't block line 62 at all because, like I said, each one of these methods, get user, get post promise, they're all using promises. And the then method in itself returns a promise. However, if the method doesn't return a promise, I believe it returns promise with the value of undefined. But don't quote me on that. Maybe you guys should do your own research. But this is just this is just a way of showing how we would want to use promises and the then keyword in a clean way. So in this function, we can just call get user promise, and then from there we can get the user's object, we can get the post, and then we can get the comments. So let's actually run this file and see what we get in the terminal. And mind you guys, I'm using Dino as a runtime because I would like to compile TypeScript without a bunch of configuration settings. All right, so the first thing we get in the terminal is hello other code firing, and then we ultimately just get the comments because in this example, all I'm doing is logging the comments. But this looks consistent. We have a post ID of 101 and 101, so things look to be pretty consistent. Finally, before this video ends, I want to show a real world example of how we may use promises to get actual data. So I have this index file, and this is actually using the fetch API or the fetch function that allows us to interact or communicate with an API. And as you guys can see, I have a server running at localhost 3000. I actually have a JSON alternative that I'll actually run here. It's called JSON server. So let me just run this. And now that I run this, I can actually I can mock data with a JSON or a JSON file. So as you guys can see, I have an index.json file. So I have an object with a user's property, a post property, a comments property. So let's use this to actually mimic real data and rely on the fetch method. So if we go back to the file, we'll see that we have the function fetch actual data. We're going to call fetch and we're going to attempt to get the users from this endpoint. This will inevitably return a promise. However, the value we get from this endpoint inevitably needs to be converted to JSON. So we'll return it to JSON. Once we actually convert it to JSON, we then actually have an array of users. And from there, we log that and we use those same users, or we use the first user to actually get the post with this fetch API, and we keep doing the same thing. So this is a very, very similar example to what we've been doing before. But instead of using set timeout, we're actually using real data, real mock data, and we're actually using the fetch API. So we're doing something that you would actually see in the real world, like a network request. So let's actually run this file. I'm going to say Dino index TypeScript, and I have to allow permissions to that server, I'm assuming. And as you guys can see, we said app function finished executing. So this was the first thing that actually ran, which is expected because, like we guys saw, all of this code here is running asynchronously. Also, guys, also keep in mind how we're also flat chaining. We're not doing any deep nesting or anything like that. So this line is actually the first thing we get in the terminal, and then from there we get the users, we get the posts, and we get the comments. So we get actually all the expected data. And if you guys look at this data in the terminal here, Hakeem, and then first post, second post, this is for Hakeem's user ID equals 1. And then the comments, nice post, very helpful. If we go back to our index.json file, we'll see that this matches up. We have an ID of Hakeem. We have his ID being tagged for first post, second post, and we'll see the comments associated to that user is nice post and very helpful, which is what we expected. So this is essentially my video for promises, guys. I hope that was insightful. I hope you guys learned something. there's anything that you guys need, or if you guys have any questions, please let me know. And I'll also drop all the source code on the GitHub repo. Have a great day.